phosphorus with the sulfur. So we're going to get to use the star on this, and we're going to see how the oxygen is going around it. Make the 5 bonds. Okay, it's going to be a fun one. Way back, I can't tell if it's in frame or not. So there we go. We got phosphorus. We're going to do the star. We're going to have 2 pointing up that way to 1, 0. 1 down there, 1 this way, and 1 that way. That's P. Now our S, as we kind of do with green. So there's 2 here, so watch how we can do this. We can go that's the sulfur. Over here's an O, here's an O, here's an O. So those are the bonds. Those are yellow. Yellow somewhere here. So you gotta remember, sulfur's in the oxygen family. You can have 6 bonds, but in this case it's only gonna have 2. 4 are gonna be the 2 lone pairs you could think of. So sulfur's in there. Now the oxygen, see what these get to go to. In ParaTHIon, there's also a methyl ParaTHIon, so there's just either 1 carbon, the CH2, or there's a methyl, which we're going to make on here. So we'll put the methyl on the end. So 2 diamonds. And they're just methyls on the end, so CH3, CH3, CH2, CH2, if you want, color in the oxygens. You can even take a break and color in the carbons. I should save my colored pencil because this is the last black one I got here. So colored pencils really works good on this carbony kind of copy paper. It was something that was in triplicate. So that's those 2. The sulfur's taken care of, so we have 1 more. Technically, phosphorus is taken care of. So let's take our yellow crayon. But this is a pretty cool molecule. A phosphorus bound to a sulfur. So it's a great example to show the double bond of sulfur is just like the oxygens having 2 bonds. They're in the same family. You look in the periodic table. And these have aliens, so if you want to draw aliens in there, go right ahead. It'll look more colorful here. More childlike, more fun, huh? Pair up there, pair here, and these guys. And you're going to have a pair here. So coming down here, now we're going to have a benzene ring. That's no biggie. Off here, let's just make it all diamonds. See how that turns out. So there's 1. What do we do? Here we do brother, sister. And 1 diamond by itself down there that's going to have an NO2 off the end. Ooh. That's going to be one of those strange bonds. And it's probably going to have a plus on it to have that many oxygens. This is where we have to draw it realistic. It's going to have a single bond, and it's going to have to share the other double bond because there just aren't enough bonds for nitrogen. I'll almost guarantee there's got to be a plus on that because it's got 1, 2, 3, 4 bonds on it. So we can handle anything now. That's the NO2 group. The carbons coming in here. Guess any which way you want to do it. Go single to double to single to double to single to double, which means I should have had this one go there. So got to white out that, find out my little stickers, wherever those are. Any kind of stickers you find, white the outlines of little name tags. Work excellent. So, double bonds, as soon as you do the double bonds, color them in there. There's a double, single, double, single, double. So when you got the paper, the sticker whiteout thing, markers work really good over those. So there's a carbon diamond. Single bond to that, diamond. Diamond. Oh, see, I'm coloring them in before I did them. So we're going to have one dot. It's got a bond, one dot, one dot. Speed things up here a little bit here. ParaTHIon. So there you are. ParaTHIon. See where the oxygens are. Got electron density here, methyl carbons. Electron density all around this. So this is where it's going to break up in water. It's another one of those organophosphates, they're calling them.